Hello and welcome to EGM702, Week 4, Part 1, Introduction to Change Detection. In this week, we are going to be looking at change detection and change analysis using remote sensing. So how we can use remote sensing images to study changes in the Earth's surface over time. We'll start by introducing change detection and then talk a little bit about different techniques that we can use in order to analyze changes in the coming lessons. So far in this course, we have been mostly interested in looking at individual images. So how we can classify a single image in order to learn something about the Earth's surface. When we start to have multiple images, and especially from satellite archives that now stretch back almost 50 years, we can start to look at changes over very long periods of time. As you can see in the animation here, we have an animation of satellite images starting from 1972, stretching up until today. And as we're looking at this moving forward, we can see all sorts of different things changing. We can see snow appearing and disappearing. We can see vegetation starting to come back after a volcanic eruption. We can even see logs on the lake moving around with the seasons. So there are all sorts of different things that we can study when we have multiple images, and that's a little bit what we'll talk about in the rest of this lesson. When we're looking at change detection, we're looking at analyzing changes over time. Now, this could be analyzing changes in the growth of urban areas or changes in land cover or land use. This could also be changes in burned area if we're interested in studying forest fires. We could also study landslides and other hazards. All of these different things are applications where we will be using change detection. We're often looking for quantitative analysis as well. That is, we're looking for things like the percent area change or the number of landslides over time. We might also be looking at the spatial distribution of these different events or the spatial distribution of change. And we might also be interested in doing some kind of accuracy assessment to determine whether or not the changes that we see are real or if they're just random noise in the images. When we are embarking on a change detection study, there are a number of different things that we need to consider. We need to consider the time that the change is taking place over, or the time of year. We also need to consider the remote sensing data that we have available, and we need to consider whether or not we need to think about whether or not we need to geometrically or radiometrically correct our images before we embark on our change study. One thing to think about as we're looking at change is how big is the change. So for example, we're looking at these glaciers flowing in this image, and you can see lots of different things happening, but for now I want you to pay attention to this large glacier at the top of the image. This glacier is flowing fairly steadily and fairly slowly, but these are very large changes that you can see. These moraines are moving at maybe a few hundred meters per year. So the question then is, how big is this relative to the images that we have? Is this something that we're going to be able to see over a couple of days? Is this something where if we have two images that are spaced by maybe a month, are we going to be able to see the changes? Or do we need to wait a little bit longer between images in order to be able to see it? Related to that, of course, is how quickly the change happens. If this is something that takes several decades, then we need to obviously wait several decades before we can start to see these changes. Is the change seasonal? We see a number of different seasonal patterns in these images. To start with, we see the snow as it falls at lower elevations into the fall and winter, and then during the spring and summer it's retreating as it melts back up into the mountains. We also see a seasonal pattern in the glacier flow a lot of the times, and we might also see seasonal patterns in things like the river flow and the presence of clouds. All of these different things are things that we need to think about. We also might be interested in thinking about the time of the year that we're either observing at or the changes are happening in. We need to think about things like the sun angle. So we want to make sure that when we're comparing images from different years or different times of the year, the sun angle is approximately the same so that the changes that we're looking for are not overwhelmed by the changes in the sun angle or differences in illumination. And finally, we might need to consider tidal differences when we're looking in coastal areas, as at different times of the year, the tides are going to be different at different times of day. In terms of our remote sensing data, there are a number of things that we need to keep in mind. We need to think about the resolution and remember that there are a number of different ways that we can consider resolution of a remote sensing system. We can think about the spatial resolution, which is the smallest object that we can see with our sensor. So if our changes that we're looking for are happening on a spatial scale that is much smaller than the spatial resolution of our sensor or of our system, we're probably not going to be able to see them. And remember, the spatial resolution of a sensor is not the same thing as the pixel resolution. We also need to think about the spectral resolution. So remember that changes in objects, or if we have objects, for example, thinking about deforestation. So when we have deforestation, we're seeing a change from forest cover to something that isn't forest cover. And that change might be more obvious in certain spectral bands than in other spectral bands. So if we're looking for certain changes and we know to expect those changes to be more obvious in certain spectral bands, we want to make sure that our sensor is actually observing those spectral bands. We might also want to make sure, if we're comparing sensors or if we're comparing images from different sensors, we want to make sure that those spectral bands from each of those sensors line up so that we can actually compare the changes from one time to the next. We also need to think about the radiometric resolution of the sensor, because very subtle changes or very small changes might not be visible in a sensor with very low radiometric resolution. And finally, we need to think about the temporal resolution of our data. So how often we get repeat data. If we're looking for changes that happen very quickly, then we want to, then having images every 5 years or so is not going to really help us. We need something that has a higher temporal resolution than that. We also need to think about the look angle of our sensor, because as our sensor is acquiring data, if the look angles are different, then we might need to take that into account when we are doing our processing. And finally, we might need to think about the type of sensor that we're working with. So for example, if we're primarily looking at optical data or microwave data, or if we're trying to somehow compare the two or combine the two somehow, these are things that we need to think about. In terms of geometric and radiometric correction, we usually want to make sure that our images are geometrically corrected, because we want the differences that we're seeing to represent actual changes in objects on the ground. We also normally want to have accurate length and area measurements, and if our images are not geometrically corrected, then we can't get accurate length or area measurements. We should also make sure that the images are co-registered, because we want to make sure that the changes that we are seeing are happening in the same location in each image, and that each image is lined up so that we're not also seeing shifts between the images when we start looking at changes. We also want to make sure, usually, that our images have been radiometrically corrected for many of the same reasons as we want them to be geometrically corrected. Atmospheric and environmental conditions can vary between different images, and we want to make sure to minimize these differences as much as possible, at least for most applications. Whether or not we really need to do this, again, is going to depend a bit on the application, and you need to think a little bit about what it is that you're trying to see, what images that you have available, and whether or not you really need to do this sort of correction. So to do change detection, we have a number of different techniques at our disposal. Which technique we are going to use, again, is going to depend on the changes that we're trying to see and the data that we have available. The next lesson we will talk about is going to cover visual analysis. So this is, for example, where we're viewing images side by side and looking at changes or trying to discern changes from those images. We often use this to help us determine which technique might be most appropriate, again, given the available image and given the available images and the changes that we're looking for. The next category of technique we might consider is data transformation. This might be a principal component analysis, which can help us to reduce redundancy in the data, highlight variations or differences. This can also be very difficult to interpret, as it's not always clear what the different principal components relate to. We can also create normalized difference indices, either of individual bands from two different points in time, or by using band ratios, normalized difference indices, or other metrics. Band algebra, such as taking a band ratio or a difference, can also be a way to enhance the differences between images at two different times. We can also do a classification comparison, where we classify each image individually and compare the results. This might not always be the best option, however, as classifications can be noisy, and any differences that we see might not reflect true changes. In part 3, we will talk about a technique called change vector analysis. This is something that can help us identify spectral changes based on the magnitude and the direction of the differences, and again, we'll cover this more in part 3. Unlike classification comparison, multitemporal classification seeks to classify the actual changes that are happening. So for example, we might see a change from bare soil to crops, or from forest to urban areas. We'll talk more about this in part 4 of this week. And finally, if we have a sufficient density and number of observations, we can analyze the data as a time series. The example here showing a time series of glacier elevations, and we'll talk more about this in part 5 of this week. To sum all of this up, we often want to analyze changes over time. This could be before or after an event, such as a landslide or a hurricane, or it could be more gradually over time at two or more points. When we are doing change analysis or change detection, we need to consider both the changes that we're looking for and the available data that we have. Visual analysis can be a first step in looking at the images, seeing what changes we can identify, and then picking what we think might be the best technique to use, or it can be a way to analyze changes on its own. A lot of the different techniques that we've covered so far, either in EGM3 or up to now in EGM702, can be adapted to analyze temporal changes. And again, we will talk more about this as the week goes along. There are a number of different additional resources that you can consult as we talk about change detection and change analysis. Chapter 7 of Lillesand, Kiefer, and Chipman. Chapter 12 of Jensen is another really good resource. And I've put a review paper from 2004 up on Blackboard that talks about a lot of different change detection techniques, and a couple of web links that you can look at to go look at different articles from NASA looking at changes in the Earth Observatory, or a video on using change detection using Landsat 8 images, and another video looking at change detection using Landsat imagery. That's all for this lesson. I hope you found it interesting and useful, and if you have any questions, please don't hesitate to post them to the discussion forum on Blackboard. Thanks. Bye.